So water accounts for roughly 60% of the male body weight and 50% of female body weight, and most of that is what is called intracellular fluid, fluids contained within the cells. So water accounts for about 2/3 of your total body weight, and a solution is a uniform mixture of two or more substances. In order to create a solution, it consists of a solvent or a medium in which atoms, ions, or molecules of a substance called a solute are individually dispersed. So in the body, the solute is generally water. Properties of water. It has a high solute, which means it has the ability to dissolve a solute in a solvent to make a solution. It has reactivity with most body chemistry occur. It has a high heat. Water has the ability to absorb and retain heat. It also has the properties of lubrication to moisten and reduce friction. The properties of aqueous solutions, if we look at ions and polar compounds, they undergo ionization or they dissociation in water. So polar water molecules, like we spoke about in the last lecture, form hydration spheres around ions and small polar molecules to keep them in solution. So what does that mean? Let's have a look at a diagram. So here is on the left, we have our polar water molecule. Remember, we have the oxygen molecule and then we have two hydrogen molecules, but they're attached at one end of the oxygen molecule, making that one end of the molecule, one end of the compound is more positive than the other end. The other end is now negative. All right, now if we look at something like salt being dissolved in water, then the water surrounds the chloride atom and surrounds the sodium atom to keep them from coming together. The same happens in glucose. So this helps in the solubility of the compounds. So just revising here, the water molecule, the oxygen forms a polar covalent bond with two hydrogen atoms. Because both hydrogen atoms are at one end of the molecule, it has an uneven distribution of charge, creating a positive and negative pole. Sodium chloride in solution, the ionic compound such as sodium chloride dissociates or dissolves in water as the polar water molecules break up the ionic compound in the large crystal structure. And each of the ions in solution is surrounded by water molecules, creating hydration spheres. Glucose in solution, the hydration spheres also form around the organic molecule containing polar covalent bonds. If the molecule binds water strongly, as does glucose, it will be carried into solution. In other words, it will dissolve. Note that the molecule doesn't dissociate as occurs in the ionic compounds. So these are important electrolytes that dissolve in body fluids or dissociate, which means they break apart and their ions are released. So the most common is sodium chloride, which when ions are released breaks up into sodium and chloride. Potassium chloride, which breaks up into potassium and chloride ions. Calcium phosphate, which breaks up, as you can see, into calcium and phosphate. Sodium bicarbonate, which breaks up into sodium and bicarbonate. Magnesium chloride, and then sodium hydrogen phosphate and sodium sulfate. Looking at the properties of aqueous solutions, electrolytes and body fluids, electrolytes are inorganic ions that conduct electricity in solution. So electrolyte imbalance seriously disturbs vital body functions. So one of the important things that the medical officers and the nursing staff will do is that they will look at the blood results and look at the electrolyte balance for the patient. When a person comes into emergency, the first lot of blood that will be taken will be a full blood count to see if there's any infection with a high number of white blood cells, but also a full electrolyte count to see if the body's in an imbalance of electrolytes. So the properties of aqueous solutions, we've spoken before about hydrophilic and hydrophobic compounds. So hydrophilic is water-loving. They interact with water, and this includes ions and polar molecules. Then you have hydrophobic, where they fear water. They do not react with water. And this includes non-polar molecules, fats and oils. Then we have colloids and suspensions. So colloids are a solution of very large organic molecules. Say, for example, blood plasma that has large blood proteins in it, and that is called a colloid. A suspension is one in which the particles settle. If you shake it up and then you let it settle, then for example, if we look at whole blood, if you had a tube of whole blood and you gently agitated it and then set it down, what would happen is that the whole blood components would settle out of the blood serum and you would see a definite line. Another important concept for us to be able to understand is concentration. So concentration is the amount of solute in a solvent, and it's measured in milligrams per milliliter or millimoles per litre.